Sup, ladies of Georgia Tech. I don't know if you guys have seen that crazy YouTube video about the world's largest rope swing. Well, let me give you this. Imagine if I had a really long rope and you were riding on it. Let's see how fast you're going. Well, to do this, we simply just use the energy principle, where you have energy initial on one side and energy final on the other side. You can see it divided right here. Now we know the kinetic energy of initial is going to be 0. So we simply use all the rest of the variables and plug in different values. For example, we use 70 for the average mass of an adult human, 9.8 for our gravity constant, and 30.45 for the length of our rope. Over here, you can see this constant, 3.048. Now this is the length of the person hovering above the ground. Now, we plug in all these variables and we solve for final velocity here, and we get 23.2 meters per second. That's pretty fast. Sup, babe? I know you're feeling the tension because I didn't really invite you to my formal and all, but don't sweat it. You know you're my only girl. Now, speaking of tension, we move on to question 2. The force of tension is equal to the force perpendicular plus the force of gravity. Now we know that the force perpendicular is equal to the mass times the velocity squared divided by r. Now we know r is the length in the x direction, if you remember from the chart that I drew in problem 1. Now once we plug in all the variables that we have here, 70 for the weight, 23.2 for the velocity, 45.72 for the length, and again 70 for the weight and 9.8 for gravity, we end up getting a force of tension of 1,510.78 newtons. So I know our relationship's moving kind of fast, and so is this rope swing. Moving on to question 3, we got to try to find the max speed at 30 degrees. Now doing this, we have to find force perpendicular. Now force perpendicular simply equals force of tension minus force of gravity. But don't get too excited because we have to solve for these two things. They change when we go at a different degree. Right here you can see the force of gravity and force of tension solved out. For force of tension, we simply took the force of tension from our rope just hanging straight down, as you can see here, and divided it by cosine of 30. For force of gravity, we took the mass times the gravity and multiplied it by the cosine of 30. Now this gave us these two values right here. Now we know the force perpendicular is equal to this equation right here, mass times velocity squared divided by r. We already know these constants right here, and we take the difference of these guys and we solve for this velocity right here. This gives us a value of 22.4 when we're at 30 degrees. Man, we're speeding up, girl. Woo, it's getting sunny in here. I should put back on my shades. And move on to problem 4. Now problem 4 asks us to find the stretch of the rope when it's just hanging down. Now we do this by using force of tension equals Ks times the stretch. Now we got a Ks value of a nylon rock climbing rope online, and it was 8.7 times 10 to the 8th newtons divided by meters squared. We used this value and plugged it in this equation using our force of tension that we found earlier and got a value of 0.0000176 meters. It's not very much. It's a pretty strong rope. Alright, so now we're moving on to problem 5. Now we're still assuming we're going to have the same rope, so we're using the same Ks value. And for this, we're trying to find the stretch of the rope when it's at 30 degrees. If you remember, the force of tension is a little higher, so we're going to expect the rope to stretch a little bit more. Now we plug in our values right here, as you can see, and we do get a value of 0.00002 meters. Now, I don't know about you, I think I could stretch you out a little bit more. Now here comes the coding part of this experiment. As you can see over to our left, this is my entire code. And over to my right, you can see all of my printed values. Right over here, where the ball is closest, or where the string is closest to being straight, you can see that I have a force of tension of 1,136.39. Alright, the next part involves looking at the actual VPython program. As you can see, the ball is falling straight down all the way, just like the swing we saw in the video. Alright, this has been J.K. Amsball, aka Dr. Frat Daddy, signing out. Peace, ladies.